Welcome to the upstreamlife.com. I'm your founder and editor, Vishal Krishna. I love talking automobile, and in automobile, I like talking EVs because it's about efficiency of the motor, and the distance traveled. That's what all the fleet operators want. I'm going to be talking about the commercial vehicle space, and Planet Electric is building a beautiful and aspirational vehicle for you guys, you fleet operators out there. Welcome, Gagan.
Thank you. Thank you, Vishal, for having me.
You're the co-founder of Planet Electric. Quickly, what are we going to discuss in the podcast?
Well, we'll go through what is this lightweighting tech,
And what else?
and how does it improve economics, which means the transition from diesel to EV is much more smoother, and you don't have to pay extra bucks. We'll discuss a bit of supply chain, founder issues, EV issues.
Yeah. And in the end, it's all about the fleet operators being happy with the cost.
100%.
Thanks to lightweighting.
100%.
Efficiency increase, more miles, more cycles.
100%. Yes.
Gagan, thank you for coming to my podcast. And, it's always a pleasure to talk to somebody from the automotive side. And you yourself have been in ISRO in the past. So it's great to talk to a space engineer who's now doing EVs. I want to get into all that. Tell us a little bit about Planet Electric.
Thanks, Vishal, for having me. I don't think I've done this before. So, fingers crossed.
It's always the first time. It's going to be good, don't worry. It's going to be good. Go for it.
So Planet Electric was born because we wanted to really make automobiles efficient. We come from the launch vehicle space, rockets, colloquially. And the fundamental thing we do is lightweighted. Like, you do not put more mass than there is a requirement. Otherwise, your payload delivery takes a massive hit. Same is the case with EVs, right?
I own an EV, so I know.
Yeah, you can't refuel in the middle.
Yes.
So you need maximum efficiency to take your payload, that is you, from point A to point B.
Correct.
And I think from the last 50, 60 years, look at diesel, right? 11,000 kilocalories or calorific value per liter. Batteries, 300 per kg. There is no comparison, right?
No comparison is not.
So that's why you see now these legacy structures not working out. That's why Planet Electric.
Okay, this is interesting. So a lot of people will get confused.
Yes.
You are one of the few. I've seen the designs that you make. So it's very futuristic for a commercial vehicle. It's the entire structural part that you have IP to.
Yes.
But Planet Electric manufactures by getting a lot of vendors, and then you build the vehicle yourself. It's a 1-ton vehicle, or slightly heavier, 1.5 tons. Or 2 tons.
So we will have 3 variants.
Go on.
We are getting out the first 750 kg to 1-ton variant. The next one is 1.5 tons, and the last one would be 2.5 tons.
Okay.
With this, we'll be able to cover the light commercial vehicle market.
So would you say intracity or intercity would be covered?
Correct. So right now, starting with intracity to intercity.
Hub and spoke. Okay, brilliant. So now I talked about the design. You're one of the few commercial vehicle companies in the EV space that looks really like an EV, right? The design does,
Yes.
right? It's not like retrofitting into some kind of a 1-ton truck and then...
Yeah, to be very honest, we don't even have those legacy molds, so how would we?
Yeah, absolutely.
Yes.
So talk about your modular approach to the business.
Yeah.
How old is the company? I know you're in the testing phase, you're in the prototype stage.
Yes.
So before you got there, how did the idea happen?
Absolutely. So we started in 2021. I quit my consulting gig within the space industry to start this. Really, to your first question, it's important to do what we know really well. And if we do not know something 100%, best to outsource it to a vendor who's doing it in millions of pieces. You get economies of scale from there. You get fundamental innovation from here. You can either translate that innovation to performance or cost as the market requires it, demands it. And then, of course, the software and the data layer is something that is yours already. So that makes it fairly straightforward. Okay, this is what we are going to do. This is what we need vendors for. Today, as you rightly said, we're in the prototyping phase, just about to go into testing in May. April end, we'll showcase the first functional prototype. We already showcased the lightweight chassis a little earlier, 10 days ago. So during this journey, of course, the first year, it almost, took just getting the R&D, just figuring out materials, figuring out sources of materials, how to manufacture something. There are multiple techniques, what best to choose, talking with multiple suppliers, what are the, how do we get confidence of bill of materials. Of course, when we started with a passenger car. And while the realization took some time, but the GTM for passenger cars can be exceptionally hard. Marketing, right? Retail, and we sort of took that hint from the market as it was telling us, or probably shouting at us, change, and it couldn't have been better because we saw a much bigger opportunity in the commercial vehicles, right? And not just from a market point of view or a product fit point of view, but also from a carbon footprint point of view. The biggest carbon footprint is generated by commercial vehicles, not passenger vehicles. So might as well,
transition there. Yes. And it was a quick transition. And when you look at say CV space, the customers would be the large fleet operators would say, I want a particular design at the maximum payload. Can it have the maximum distance, right? That would be the question, right? What are the first cues on why do we have to do commercial vehicles?
Right. So one of the first conversations I had on the commercial vehicle was with Mragank at Moving. He's running this 3PL company, very successful. Yeah, he also started in 2021, but all electric. And he was very clear, the current vehicles he was getting on the four-wheeler side of things was just not making the business cut. It's too expensive compared to your diesel or CNG ones. Very high EMI. There is business uncertainty in this segment, which means if your EMI is always high and your business is up and down, then you're not sure where your month is ending.
Yeah.
Lots of stress for fleet operators who basically function at about 10% profit, 15%
This
profit.
is with the legacy product also.
This is with the legacy product as well.
Okay.
Correct. So ultimately, when EVs have to come, it's not like freight companies are giving third-party logistics more money to transition into electric. Costs will continuously keep going down. Probably a few global players can offset it because, hey, I mean, we have a mandate. But still, there are business costs associated with it and boards will never approve. So, yeah, that is where we got started because the requirement was, and we was like, okay, we have this technology that we've been building for cars, but now I think it makes much more sense in cargo vehicles. And then the conversation immediately was, yes, that's exactly what we want because we can't make business sense with the current vehicles. So you lightweight it, less battery, so lower upfront cost, give it to me at this cost and give it to me at this kilometer per kilowatt hour kind of efficiency, and I can make my business work with it.
Okay.
So that's where we've sort of worked backwards and figured out a vehicle that would work.
It's interesting. You've taken the OEM approach where you work with a lot of vendors.
Yeah.
And you have battery, motor, obviously other chassis that you build yourself.
Yes.
Right. Which is interesting. And then you have the telematics.
Yes.
So you have to bring about 20, 30 vendors together in this ecosystem.
Big key vendors.
Right? Key vendors, right?
Correct.
Your early chat, I mean, obviously the economics. We have to get into the economics of would you have started the development of the vehicle basis what the customer would pay? That's how you started, right? You said per kilowatt hour.
Yes.
And per distance, probably 1 kilometer, or how many kilometers per kilowatt hour?
So right now we are really, really big. High. We're about 12 kilometers per kilowatt hour, which is really a good industry standard. Everyone else is around 6 or 7.
Okay.
So you can see the jump that lightweighting has given.
Lightweighting.
Yes.
Okay. When you have these arguments or conversations with fleet operators, do they come back and say, okay, we like this, we'll probably pre-order it or go for it? Did that give you the confidence to build the company?
100%. What most have told me, the vehicle is too good, give it to me tomorrow. Okay. I'm like, love to.
What does that 12 kilometers mean? You have to explain to our audience.
Yes.
What per kilowatt hour, if you say 12, if you compare it to diesel vehicle, or sub 1 ton truck, what are the economics?
No, absolutely. So we're talking about a 180 kilometer certification range, or about a 190 kilometer certification range for a 15 kilowatt hour battery.
Okay, good.
For say about a 750 kg payload, right? You compare traditional players within those same metrics, and you will find for 21, 22 kilowatt hour battery with a lower payload, they are giving about 150 kilometers of range.
Okay, so it's 180, 15 kVh, powerful motor.
PWH, yes.
Got it. That's fine. It's great. When you compare it to a gasoline type,
No,
What
this
are
is
the-
EV. EV
Okay, EV,
comparison.
yes,
This
EV
is EV.
comparison you've done, right?
Yes.
I get that.
Yes.
When you compare it to a
Gasoline.
gasoline or a
Right,
diesel, how do you
right.
think is the cost saving there?
Right, right. So
That's an important thing to make for
100%,
them, yes.
100%, right? So we look at the monthly economics,
Yes,
right?
please.
Typically, third-party logistics operators get about 55,000 to 60,000 rupees one shift
Income.
in revenue income,
Yeah.
and out of that, now you have driver 20,000 rupees. You have some insurance and maintenance charges, typically about 1,800 or so. Then you have your electricity and fuel cost.
Yes.
And then you have the sort of the profit,
Yes.
and then you see the margins, right? Here, I hope I'm not forgetting anything.
Don't take your time. That's why take your time.
But so driver costs remain the same.
Okay.
Your EMIs increase. So versus of 14,000 rupees on a CNG vehicle, now you shoot up to 24,000 rupees. Now that's a very big number.
Yes.
Typically, this number should be still 18 or 19,000
Correct.
rupees.
Correct.
Then from an electricity point of view, from diesel CNG, you were about 8,000, 9,000 rupees. Now you've come down to about 3,000, 4,000 rupees.
So that's the cost saving. The EMI is up, but
yeah.
balance is out here.
Yeah, but that is 10,000 rupees up, right? And here you are only able to make about 5,000 rupees. You're still 5,000 rupees in loss.
Okay.
And for a business that typically generates, say, about 15%, right? So that is for 60,000 rupees is about 9,000 rupees. If you take away 5,000 rupees, you're left with 4,000 rupees.
Yeah, that'll hurt the driver.
That hurts in a way where if you do not get the business for all 26 days, you are in soup for that month.
Absolutely.
And fleets typically have always relied on that steady cash to be able to finance your next set of fleets. वो नहीं हो पाएगा. So
that's what you're solving, right?
exactly.
So
exactly.
how would it be efficient in your case?
Right. So now instead of a 24,000 kind of a EMI, it would exactly be like a 19,000 or 20,000 EMI for us.
Okay.
Instead of a 4,000 rupees electricity cost, it's much lower. It's about 2,500 rupees
Okay.
because of our inherent efficiency.
Yes.
So so we've only increased 5,000 rupees there, but we have more or less decreased about 6,000 rupees from that 9,000
Yeah.
on the electricity side of things. So net, we are putting more money into the pocket
Okay.
of the operator. So instead of 9,000 rupees, now they have the ability to earn 10,000 rupees a month.
So you've done this after a lot of study.
Yeah.
And it all comes down to lightweighting, is it, in the end of the day?
System efficiency, absolutely, yes.
So the more miles you put in,
Yes.
the more you earn.
Yes.
And that's all. And EVs were not able to do that, so you're going to make sure that it does that. That way the fleet operators earn more money
Yeah.
and they don't complain.
Yes. And I mean, if you
Otherwise EVs won't work.
EVs won't work.
Yes.
Exactly. No matter what chemistry you take,
Yes.
right?
Yeah, you can talk the best chemistry
Yeah.
in terms of lithium ions.
Yeah.
Right? You can. Some people talk I've always said sodium also would work somewhere, but you said no, it's only for storage, it would work great.
Yeah. I mean, and you have to sort of optimize between energy density, dollar per kilowatt hour, number of cycles that you can put in a vehicle, so that battery life is decent enough, at least like 4 or 5 years.
What's the chemistry that you're using that makes it efficient?
We've been we've simplified it. We give us a cell which is the cheapest cost with 3,000 cycles.
Okay.
We'll take it. Because with 3,000 cycles, we are able to guarantee about 5 years of running with a 6-year top warranty.
Yes.
So 6 years or 250,000 kilometers battery warranty, which is really the best in business today in this class of vehicles.
Okay.
And then, sorry, I lost my train of thought.
No, we were talking about with the efficiency that EVs won't work if the cost is very high.
Yes.
So we were talking about, therefore you went into battery cycles being efficient.
Yeah, so for us, cost efficiency matters the most in Indian market. So if we've lightweighted, it's not that we are going to say, I was giving you 180 kilometer certification range, now you take 250 kilometer certification range. The logistic operator doesn't want it. Like they want to run 100 kilometers a day. I have given them 140 kilometers on road, 180 certification ka. So they don't want. So what they want is give me a lower upfront price so that my economics work. And that totally makes sense because that EMI has to come down.
That's the whole deal for them.
That's the whole deal, yeah.
So your vehicle will also run the cycle, 3,000 cycles or more.
Yeah, charging cycles, yes.
And you're also making sure that the range of 180 will be consistent throughout?
So typically you see about a 15 to 18% degradation.
After the 4th year?
No. So this is over the 5 years.
Okay, 5 years.
Now what we do is we estimate this range on 85% level of battery. So we estimate maximum the battery will come from 100% to 80%. So yes, there will be some range reduction, but not 20% because we've already accounted for some of it.
Okay, interesting. So there is an engineering. I mean, look at you. I mean, you are a scientist who has to do the engineering side.
Long back.
Yeah, long back. But
Yes.
you have to do the business.
Yes.
I mean, and the business of fleet. I mean, for those of them listening in from abroad, a fleet operation is very complicated in India, right? It can have many people who own 10 vehicles.
Yeah.
Less than 10 also.
Yes.
It's not disorganized. It's fragmented.
Yes.
Right. It's very interesting, right? 80% of that is fragmented.
It's less than 5 actually.
Less than 5?
Yeah.
And for them, the economics makes a lot of sense. So they don't care about the science as much, but they appreciate if the vehicle is light and go further. That's all they'd understand about the science.
Really.
And other than that, they just want lower numbers in terms of EMI, driver cost, to be maintained at consistent levels.
Right.
I mean, and the asset should be running.
Assets should be running and assets should have a decent enough second life value, which they've generally seen for over the last 3 decades.
What do you mean by second life value?
After 5 years, typically the asset goes into a secondary transaction and then it is used for more construction use, more like a mule use. Before that, it is more like the e-commerce use, right? So when it goes into second life, of course, within the EV era, we anticipate battery replacement. That's fine. But what traditional players have always ensured with a well-proven technology for decades is you'll always get a fixed range of price.
Yeah.
Today, that range of price...
Resale, that they call it.
Exactly. And India is a value-oriented country. So you want to understand every single of economics from day one, right? So for us, it makes a lot of sense to be able to give superior economics because right now, we really can't comment on the end what will be the value of the asset after 5 years. We know battery will have to be replaced, but the overall asset, how do you value it in a market is something new because we are a new OEM.
Yeah, it's interesting. That's what I want to ask you, right? For you to transition from that engineer to doing the business, I'm glad you went to the customer first before you start building the product. That's a typical mistake science.
No, I already had made that
you had?
multiple times.
Okay.
Yes.
So did that help? So now you have any customers saying that, okay, are there pre-orders at this point of time?
So we've from one customer 1,000, from one customer 600, and some very, very good conversations in the pipelines. Not all are formal because many of them are publicly traded companies.
Yes.
So it's not possible at this stage.
No, you don't have to disclose that. So you've got pre-orders.
Yes.
And I hope the testing really goes well for you in April, right?
Thank you. May, June. Yes.
May, June, right? I look forward to that. Okay, my question is the modular approach.
Yeah.
You went to the customer, got their thought process on the economics, and you then reverse engineered it into a lightweighted vehicle.
Yeah.
Right? Now, talking to the vendors to meet your SOPs.
Right.
Well, how tough was that? Let's say, again, more you are just in the structure.
Yes.
Right? But everything else, telematics to motor to battery is all coming from someone else. And then you have to manage your efficiency standards at 180 kilometers.
Yes.
Right?
Yes.
For a 15 kV motor.
Yes. So, we face different challenges in the supply chain, right? First is we want a 320 volt powertrain, not a 92 or a 48 volt, which means this is a high voltage powertrain. Motors are different, battery packs are different, a lot more safety goes in, redundancies go in, thermal management systems go in. A lot more complex systems go in. But then, of course, at the end of the day, give you much higher efficiency. So that's the reason you're doing it. And to also be able to make this vehicle exportable rather than just keep it in India. Then you go to vendors. There are multiple vendors, thankfully, now on the battery and motor side. When we started in 2021, there was no one. So we went ahead and did MOUs with BYD itself and others. We had some good connections on the other side.
Got it.
Because we really needed these systems. Today, thankfully, yes, a lot of localization is happening, so we don't have to go anywhere. Everything is available in India. But then the question comes, okay, the sample is available. How will I pay a design and development cost? So then you have to negotiate as a startup. I'm like, look, I can't pay this. right? I can probably amortize it in the serial contracts, but I can't do it too much, otherwise I'll price myself out of the market. So tell me what's exactly the new thing here, and then let's negotiate what best you can do for me. And that's really where a no customization rule is essential. If you customize any small thing, you can have millions of dollars and still not come out with a vehicle, right? But if you say, you give me what you have best, best cost, best features, I will figure out how to integrate it in my vehicle. No, that's my problem.
Which is
not
what
your
you
problem.
figured out.
Exactly.
So instead of owning everything,
Yes.
you've decided to
The structural bit is the foundation. Software gives us the edge, as well as certain product features like weight sensors and ML algorithms. But in the middle, all of that hardware, no, let's get it.
You just get it and then integrate it.
Yes.
That's where most of the OEMs work like that anyway.
100%.
Right?
Yes,
So
yes.
that's a good thing. So that's worked out for you. You've worked out the economics. And the vehicle, I mean, let's look at it. The average sub-ton vehicle was about 8 lakhs or 9 lakhs in cost, is it? How much
So
is it?
today, a 600 kg payload Tata Ace EV goes out in the ex-showroom price of about 11 lakhs with a fully built cargo box and everything. And then you have subsidies, but they are going away as of March 31st. So we'll not talk about subsidies anymore.
This we're talking about the gasoline part still, or the CNG, right?
No. This is your EV.
The
Tata
EV
Ace
is 11. The EV is 11. Okay, let's stick to that. 11 lakhs for an EV
Yeah.
of a 600 kg payload.
Yeah,
What is the CNG equivalent cost?
CNG equivalent, this is Tata Gold. This is 750 kg payload. 5 lakh plus taxes and all of those duties. So
what
6.5 lakhs.
and what about the diesel version?
Diesel version a little less. So diesel
less,
version is about 6 lakhs on road. This is about 6.5 lakh, and EV is 11 plus a little bit more on road.
So that's the economics of the two go-to vehicle, which is the Tatas at this point of time. But in your case, the costs are, you don't want to reveal the pricing at this point of time. I know that.
Yeah.
So you worked out the economics with the competition, and how will you price this out?
Yes. So we've been able to procure cells at a very, very reasonable price. We've been able to reduce the battery pack size itself. We've been able to further lightweight a few other systems because of the fundamental lightweighting. We've been able to save cost itself on the material. When I talk about composite materials, aerospace materials, the immediate thought is carbon fiber and all of the high costs associated with it. But we've not gone there. We've gone with materials that give us extremely high flexural strength, about 450 megapascals, and longitudinal strength of about 900,000 megapascals. To give you a comparison, mild steel is about 250, 300 megapascals in all directions.
Yeah.
So it's a really good material. It doesn't cost a whole lot, a little more than steel.
It's a mild steel alloy.
No. This is composite. These are what you call as twin-tex materials. These are a form of long fiber composites, and they've been used in multiple applications. Like we've built wind turbine blades with it.
Okay.
We've built yachts hulls with it. We've built cooling towers with it. We've built I-beams that do not corrode for structural applications.
So that's the thing that you're building. So you've used existing science to do this.
Correct. But our input is engineering.
Okay.
How do we engineer this material and a bunch of others to suit durability, crashworthiness, resistance to environmental factors, and make a sturdy vehicle out of it?
I look forward to that. Gagan, you gave me the science, you gave me the practical costs and associated fleet operators and, making their dreams a reality with EVs. It'll happen, I'm sure. And you also talked about the structural nature of the vehicle, lightweight, right? And the materials used. But what I want to understand from you is, okay, you're going to do testing in May, June. You just mentioned it. After that, what? I mean, you have 2 customers, I'm sure.
Right.
That is the toughest part of being in India.
Yes.
With every EV in the commercial vehicle space that I've seen, some of them have struggled.
Yeah.
And you know that, and you've discussed it with me once previously.
Yeah.
So what are for the audience's sake, what are those challenges and how do you want to address them?
Yeah.
And why these challenges are opportunities in an India which is transitioning to new fuels, right? Or new, let's say, new energies.
100%. 3 or 4 things, right, I would like to highlight.
Yes,
One
please.
is, don't commit the mistakes others have.
What are they?
Battery shouldn't catch fire.
Okay.
Software should work in the BMS. Software should work in the VCU. Your battery replacement or the internal insurance that you have should be lower than 5% to begin with, and then it should eventually trickle down to around 1.5%. because things fail, but you have to keep them at a statistical limit where it is ingrained in your P&L and you can still be reliably profitable.
Okay.
So you have to always continuously measure, right? So when we will test, bet you the whole platform will be full of sensors, and we will know exactly what every single parameter in the vehicle is doing, whether it is battery, motor, in the power distribution, on the chassis side of things, on the transmission side of things. So
you'll have the entire diagnostics running all the time.
absolutely, we have to, right? Because only then we understand what has gone wrong, or from a prognostic perspective, can look at what can go wrong. And there's something, because the fundamental reason for putting in a telematics unit along with VCU. Now, VCU can do all of that, but we want that real time. We want that to be fed, and our backend teams to always understand where their alerts could come, and these alerts could be passed out to the customers. Have a quick response team, say from a roadside assistance player, and a service center partnership. So if something goes wrong, get it there. The biggest failure for us would be if a vehicle goes down and we are not able to bring it up quickly. Right, and it really depends upon the type of illness the vehicle has. It could be a couple of hours, or it could be a couple of days. But we've seen vehicles being stranded for a week. That means that entire month's P&L is really massive loss.
Yeah, because the fleet operators will complain.
Oh, 100%. So what otherwise you do if there is severe problem, you have to replace the vehicle. Right, and we've seen that in the case of passenger segment, two-wheelers especially. But four-wheelers are not that prone to failure. We do extensive testing.
That's what I want to ask you.
Yes.
Yours will be certified by ARAI?
Yes, ICAT and ARAI. And typically takes a few months to do that. But what we've at least ensured is all the component level certifications we have from the suppliers. So we don't use anything that is absolutely new. We have pre-homologated components, so that the vehicle level homologation process, which is largely on the active safety, passive safety, AMI, AMC, and a few other tests, sort of go well. Again, sort of getting that timelines in order so as to not miss the production bus.
So you don't want to make that mistake also there, right? Also, you have to manage that it's safe.
Yes.
You have to make sure that it's data enabled, so that your customers are happy all the time.
Yes.
So it's almost like a predictive preventive maintenance.
Correct.
Right. Then ensuring that the product runs 3,000 cycles.
Correct.
Right?
About
3,000 cycles. So all this is planned for, and so that is just the product side. Then you have to go to market, which a lot of people fail at. And I'm glad that we'll try to put some images of your product.
Yes.
Because most of the EVs that I see on the road are like these auto rickshaws converted into with these funny looking boxes. It looks to just say, I mean, it looks like a slim man with a fat belly. You get what I'm saying? That's how they look, man. I'm sorry.
It's a very interesting description.
It is, right? It's like a box like that, and your slim body. It's very weird EVs that I see in the CV space, right? Commercial vehicle space.
Yes.
And you guys you've got a very futuristic, an aspirational design out there, which is nice. I've seen it, so that's what I mean. I also want to know the challenge to market. Do the people appreciate the design? And then from the design or they just come and say, boss, it's just the money in terms of cycles that it runs. That's all that I want.
So
I don't care what design it is.
So the design is more functional than aesthetic. The reason it is designed that way is for superior aerodynamics. While in India, these vehicles would run at 60 km per hour, the lower variants, so it doesn't matter that much. But as soon as you go to 80 km per hour, right, it matters a lot. Or 100, it matters a lot. These are the larger variants.
Yours goes at, because you're 1.5 and above.
If they will go
faster.
to 80 and 100.
Correct.
Now, this is where we want to ensure the best utilization. Give you an example, right? Traditional vehicles typically would have a coefficient of drag of about 0.45. Ours is about 0.26. So it's massive improvement.
It sits really low, doesn't tilt.
No. From a coefficient of drag point of view, how the air flows over the body.
Correct. Yes. So it keeps it stable. That's what I meant, right? It's stable at high speeds.
Keeps it stable and keeps the friction very, very low. And if you keep the friction very low, you are going to run more kilometer on the same battery and the same weight than a traditional vehicle. And I mean, of course, this is something that we learned from aerospace. But what we've seen in traditional industry is not that they don't know how aerodynamics work, is that they do have certain legacy systems. So they go there and build it. nobody has really focused on the vehicle bit of it, right?
Yeah.
Everybody has taken that same mold and retrofitted a powertrain.
Yeah, and it looks very ugly.
It does. It does. It does. It does.
I look at these EVs running in the road, apart from the two-wheelers, of course, for a fancy look. When you see these delivery boys come by, you look at them and say, man, is that an EV? But again, not aesthetic, but functional, yes?
Yeah.
So yours is functional,
Yeah.
but it's very different design, which is
Yes.
good.
Yes.
Do they appreciate it? That was my question. I mean, do they see that, okay, this coefficient drag is everything great, we like it. In F1 terms, we all discuss all
Yes.
this, right? But does the fleet operator like all this?
Yes. So there are two ways of looking at it. Wow, what a great design. The driver's just gonna
Love it.
no.
No, he's not going to say that.
They're gonna love it,
But
and
he's not
then
gonna
they're
say
gonna completely ruin it in the first year of operation.
Because they're going to hit it everywhere.
Exactly.
Yes.
Exactly. So I mean, it's India, right? The human behavior is so different.
Yeah.
You're gonna, but this is because somebody is working for the fleet. Now you say the case of driver owners, right? It's about 75% people driver owners, one truck. Now when they buy this truck, and this is aspiration. This is like you can have a camping thing at the back when you're not delivering cargo. You know, you can seat a 3 people family in front. All of that matters a lot in India.
Yeah, correct.
So I think from that perspective, it works well. We have an option for AC cabin, which truly makes it
So is it tested
aspirational.
for the weather of Delhi? Or outside of Delhi or Rajasthan or UP?
Right. So our battery packs will work. Our motors will work. All that happens in an HVAC unit, AC unit, is it is going to consume more battery. So in an extremely hot weather, if you turn on the AC, you are invariably going to get less range. And this is something that we will be able to tell you right away. Hey, if you have 400 kg load, this is your range. If you have 1500 kg load, this is your range. If you switch the AC on with it, this is your range.
Okay.
And real-time range you can see. And then of course we have speed limiters so that they cannot exceed a certain
norm. That's a
those
norm
norms.
now.
Yeah. But you have to do all of this, and you have to even be stricter in extremely hot or extremely cold weather. We're sort of just starting to adapt to how EVs work.
Okay, the appreciation, yes, it's an aspirational vehicle. I hope, if you go to America, people who drive those trucks, they really love their trucks.
Yes.
Right, America is a
Yes.
very truck country, and I hope in India also trucks are treated like, gods and goddesses, because they are the lifeline of the village that they come from in many ways, right? And I've seen single driver operators.
Yes.
And that's it's almost like romanticized in India, as stories, right? But that's the segment that you're going to. But will you do a dealership model for these guys, or will you go straight to larger fleets?
I mean, to start with, as a startup, we don't have the money to market ourselves and become that kind of a brand. So definitely B2B fleets to start with. Of course, we understand when there is good adoption, when the product quality is good. Investor dealerships themselves might approach us on picking up a few numbers per month, and that's where really the decision is ours on how do we approach that process that can scale, because we still see in various new three-wheeler players, the churn of dealership is so high, man.
Yeah.
It's almost like 50% gone in 3 months, right?
It's the dealer
Every
who
3
loses
months.
the money, actually. I mean, they have to it's cash and carry, right?
Yeah, but dealer never loses the money. You see, dealer always makes the money. It's the OEM who always loses.
Tell me how.
So
In your case, taking to your startup, if you did a dealership model, why would the dealer make money? Because it's cash and carry, right? In a sense, he has to buy. The big brands just say, take my product, pay upfront cash and go. But you get a 2% commission on the sale.
yeah, no, there is no upfront, right? There is no upfront. You buy, the OEM gets the money.
Yes.
So it would be lovely for me as an OEM to get upfront cash.
But you won't get
That's
that.
not going to
Because
happen.
of your size, inherent size, you can't do the dealer model. Got it.
Tatas can do it.
Yeah, but you can't do
We
it.
can't do
I
it.
understand.
So we have to go to fleets who understand how good we are, because they're businesses. They're not driver owners. And they want to deploy these in hundreds because they don't have any other vehicle. And we have a price point that is quite much better than
So they'll be
standard.
doing an EMI also, in your case, that's it.
100%. But we are selling it to them. The third party logistics takes it on their books, financed by financier, and they run it.
Okay, so that's great. In a sense, that way, you're just an OEM. You don't want to keep it in your books, where it's a lease model.
Yeah, I mean, look, exactly, right? Inherently, lease models will get you what, 10-20% margins. Passenger segment is different. There are higher margins, but not in the cargo segment. And then OEM, we are trying to build high margins because we are able to first bring out such a good product, keep the BOM cost at a certain threshold, and then add carbon credits and other features, data features on top to fatten up our PAT.
Yeah, so that's one way you want to differentiate yourself.
Yes,
right? In the bill of materials, you want to be a sustainable company. How do you track all this? The fleet operator, again, doesn't care about this.
No.
But what does that data mean to you?
I mean, we look back at the sort of like this LCA kind of thing, right? Life cycle assessment. So we look at per kilowatt hour battery, how much is the carbon footprint spent? Per kg of steel or per kg of composite material, how much is the carbon footprint? Typically, so you do that for all the components. So approximately you get a number, and then you assume a grid. So you can assume like India's grid is still about 65% coal, 35% renewable. So you assume that one grid. Another grid you can assume is about 50-50, which is more metro city, more push for renewables. But that's the best case scenario. If you're in Germany, you could have assumed things, not anymore anyways. So yeah, you assume a hybrid grid, and then you run the calculations for 250,000 kilometers or 500,000 kilometers. How much footprint are you going to really generate? And then you add it all up. So for, say, to be like a diesel, it's over about 8 to 10 years, it's about 120 tons of carbon dioxide equivalent. For the new EVs that are coming to replace that, but that are not lightweight. Typically, it comes to about 45-50. We are able to further reduce that to about 20 to 25. And that is really the reduction you see at the end also.
Okay.
The same lightweighting reduction, the same battery reduction, the same cost reduction, and the same carbon footprint. It fairly sort of goes proportional.
You can track that, and you can share that with your VCs if in the future, if they care about it.
Well, climate impact VCs, yes, for sure.
That's the ones that you're looking at also, right?
Also, yeah. I mean, OEMs are a difficult business to fund. Fundamentally,
you're being very honest, but you are looking for funding.
We are in the midst of funding, and we understand it's a difficult business, and we understand it's not for everyone. There is a completely different risk appetite, and you see, I mean, the amount of variables that you can control, that you need to control, being an OEM, say versus maybe a battery startup, much higher in an OEM, right? Because you have on the backside vendors and you have front side customers. As well as, but what I see is high margins.
Yeah. And
as a supplier, you're always squeezed. As an OEM, I can build the best product, put it out there, generate high margins to begin with, right? I won't sell it at a loss. I will be profitable from day one on P&L, and then keep increasing my margins and still keep the customer happy.
No, interesting thought process. So as an OEM, you're looking for money at this point of time, and anybody watching this to contact Gagan, I'll put his link in the description. You can contact him. Okay, team.
Yes.
Very important. You have a co-founder. You can call out his name.
Yes.
And his or her name.
Yes.
And then you could talk about the team. How essential is it to surround yourself with good people at this stage? How tough is it to keep good people?
Absolutely.
But I'm sure EV talent is something that you're building. Just like years ago, they built talent for e-commerce. All the FMCG dudes joined e-commerce, and now we have e-commerce as a talent in India. So similarly with the EV segment, right?
No, so approach has been to cover all areas. So it's me and Prakha. We took part in a major college project where we were building a sounding rocket together with a bunch of friends and scientists from ISRO. We learned a lot there. We had the opportunity to lead the team, built a rocket, fly to 16 kilometers as students, and then we remained in touch. We've done a bunch of things together. So this 15-year relationship sort of built into a co-founder relationship.
Okay.
Right? So which means I never have to worry about anything from a co-founder engagement perspective. We always have each other's backs. We have a really wise mentor with us, Sanan Sharma. He comes with years, decades of experience with them.
Sanand Sharma.
Yes, and but right from GE to owns Corning to Alstom to multiple businesses in India, set up, run large manufacturing heavy businesses.
Okay.
Right. We have Sujit, who just retired last year from Bosch as their president for powertrain.
So you have a good team around you.
Yes, we've Randhir, albeit not full time, who just came out of Niti Aayog as a director for EVs, having like the policy side of things. We have engineering, hardcore engineering. We have engineers from Stellantis, Hyundai, Tata, again Bosch, and a bunch of other players who know exactly what they're doing, right? So when it comes to body in white, the structure building. So we are coming in from the composites angle. This person will come in at from a sheer experience. This is how it's done. Like, okay, now we can do this. So this is the amalgamation of these two thoughts that creates an innovation. Because if we innovate without industry standard, I think we might end up reinventing the wheel. We don't want to do that. We want to build on top of that. Same thing is with vehicular control unit. Same thing is with a battery pack engineer. Same thing with vehicle dynamics. Then we have a couple of young guys, or 4 or 5 young guys who have nothing to lose.
Yeah.
So one would just lead ops. One would lead as a chief of staff, marketing. Functions where you learn on the job, very specific to the job, and bring out the creativity as it comes by. So that kind of a mix of a team, right, literally from 21 years old to about 75 years old, is how it looks like.
I appreciate this, that I mean, it's a hustle. You have to build a team.
Yeah.
You have to work with vendors.
Yeah.
And I appreciate you flew down for this interview from Delhi. I really am thankful for that. The life of a founder is very hard, and the EV industry is so nascent. You spoke of the mistakes that nobody should make in the EV industry. I think, is there a collaborative approach where today there are certain brands getting all the PR? I think one of them deserves it, and one of them has the money. Right? So, what is the support that you need from the ecosystem? You had an H&I from the industry, one of the large industrialists in India, come and say that, look, I'm going to support you.
Yes,
right?
yes.
Do you need more of that rather than the headlines saying that India is growing, EVs will come in, different energies, different batteries.
Right.
All that is okay, we'll get there. But the money is important. Again, I talked about the VCs, but now I'm talking about the support ecosystem, that money that you got enabled you to grow thanks to this industrialist.
Absolutely.
You need more people coming in.
Absolutely. And kudos to Mirik, by the way. Just shout out to him.
What's his name?
Mirik Gogri. And he supported tons of startups like us, put in that risk capital when no one would. To propel us to a point where we are able to show something as hardware. And this is largely because there was an immediate frequency fit. He's from a metallurgical background. We are doing something in material science. Yes, exactly.
He's from the chemical business. So
chemical business, correct. It's very important to have that fit, because otherwise, how do you really evaluate? I think most investors would just go round and round in evaluating. Like, okay, we don't even have the metrics to understand whether it's a success or not. Right, that's the problem that we face as deep tech. So kudos to him. And to your question, yes, we need more. We need more such evangelists and believers in us and champions of us at every stage. That was a stage where we were building the tech. This is the stage where we are prototype testing. Next will be the stage of production. Then will be the stage of scaling up. I think people who have really done it at those stages and understand that. Typical industry, there are 2 types of industry experts. One, 30 years into the business, we've tried, this can't be done. Second, you know what, we've tried 100 things. I think this is a 101st thing. Let's look at the first principles. Makes sense. Let's do it. We'll see. That's what we need to sort of keep going.
Yeah, and I think champions are needed, right? I think Delhi has led the way in complete, CVs getting the EV way.
Yeah, even Bangalore, to be very honest.
Yes. At least in two-wheeler segment more so.
Yes.
But do you see that changing across the country? And there's an opportunity. What is the market opportunity for people to understand, if there are fleet operators out there? You spoke about the early economics, that the prices drop as more people adopt.
Yes.
Right? So do you see what are the states or cities that are going to, approach EV first policies for CVs, although there are policies out there, I know. And what is the opportunity in terms of sheer numbers? I mean, when I like tracking passenger cars, I know we do 3.5, million
Yeah.
every year.
Yeah.
And bikes, we do about 15 to 20 million, depending
yeah.
on a good year, bad year.
Yeah.
What are the numbers for this?
So for the light commercial segment, which is largely on the spoke, where you are unloading from the big vehicles and taking it to the cities, milk runs, there's about 550,000 of these vehicles sold every year. The main players in this are Tata Ace and Mahindra Boleros. They have their own segments.
They are the CNG gas and the gasoline
And the diesel ones.
And the diesel
And
ones,
of course, then you have Ashok Leyland, and then you have Volvo Eicher, and a few others. Yes, right. So they are the entrenched players. Now, with Delhi announcing urban electrification on four-wheelers, two-wheelers, three-wheelers, four-wheelers, by 2030 compulsorily 100%. We clearly see national capital region being transformed.
Yeah.
But there is an immediate need. Right? Out of this 575,000, you're typically looking at 10% right in that area.
Okay.
Then you have the Mumbai metropolitan region, you have the Bangalore metropolitan region, soon Hyderabad, Pune. You see how government is positioning from a green transition point of view. So it's not just EV, of course. You will have biofuels as well, and you will have hydrogen on the bigger trucks as well. So government is very...
Hybrids, you mean?
No.
Hydrogen also coming in? Is for hydrogen?
For the larger trucks.
Okay. Hydrogen is a different topic altogether.
Yeah,
so
let's not get into that.
Yeah.
Yes. So we definitely see metro cities being the flag bearers. If Delhi has announced it, yes, a few other cities will announce it. And states don't want to be left behind. And some of these metropolitan areas have also been really pushed with pollution, other things. And it's everything included, right from the functional bit of it, reduce the footprint, to electrify, because we also have a target to reach from a carbon footprint point of view worldwide. So I definitely see 50% of this definitely being electrified by 2030. The problem is we've gotten a very good cost on the batteries. We've gotten very good motor and software efficiency. You're missing this third leg of the stool that you sit on.
What is it?
Lightweighting. Because without inherent system efficiency.
So there's a moat. You're saying that's the moat for you.
That's the moat for us. That could be the moat for anybody who goes fundamentally into it. Give you an example. General Electric, Pratt & Whitney, Rolls-Royce have all had engines. They've all created incremental innovation and celebrate throughout it every year 1 to 2%.
Correct.
And suddenly you replace the fuselage, aluminium to composite, you get 25% fuel efficiency increase. A350, B787.
Yeah.
So materials have a...
So that's the inspiration for you, isn't it?
Definitely. I mean, we've seen it in rockets and satellites, 100%. Like we've built these structures. We've conceptualized them, we've simulated them, we've built them, we've tested them, we've flown them. We know these things work. And in aerospace, you only have 25% margin, by the way. So if something has to take a load of 1, you design it at 1.25. In auto industry, land mobility, you design at 4.
Got it.
So there is enough margin that we've already provided if something goes wrong.
Okay, got it. I mean, I really think you are a science guy at heart. I can see that. I want to ask you a few final questions.
Yes,
I mean, the inspirations. Who are your inspirations currently and in the past? And why become a businessman? You have a business background, actually. So, in a sense, your father.
My dad,
your dad, and before that also, right? So, is that the reason you started up? That, look, I've worked enough, I want to be a business person? Or is it just saying that, look, I'm a science guy, I know there's an opportunity, let me go do that? And it's a big risk for a science guy to do it, because you would have been paid very well working in some place.
So it's a mix of both. Well, number one, I think in my initial years, I never thought about business. I always wanted to do something, maybe in astrophysics or aerospace, really build things or research on things. I think this was a bit later after college that this phase started. Definitely wanted to try out a few things and see how markets work. And to be very honest, how humans work. And
that's tough to handle also.
That's tough to handle. But it has been a long journey. I mean, I've been handling this for now 10, 12 years, so I have learned a few things. So I've had my failures. I did a couple of edtechs, gave it to my founders, and before starting this, right? So I saw a few cycles up and down to really understand what works, what doesn't work in a startup, what needs to happen. But this internal kida, right? Just to
Go do
just to
something.
push the boundary. And sometimes you can't push a boundary just by being in an organization.
Got it.
It's I would have loved SpaceX to have been in India, and I would have worked for them gleefully. That's not the case.
I get the point. You want to start up because you want to prove to yourself that you can push boundaries.
Yeah, yes.
Which is nice.
Yes.
Right. So you're inspiring yourself to do this. It's great. What about books, movies that inspire you? Do you get time at all? I don't think.
I used to get time.
Not anymore.
Not since the last year or so. It's been difficult.
Okay.
But I have watched ton of Netflix. I've got bored of it.
Yeah.
And not really books anymore, unfortunately. But I do read up. Whether it's scientific articles or other
Journals.
Journals or in-depth pieces
Okay.
written on tech.
So when you look at the world, there's some foremost people doing space stuff.
Yeah.
Do you look up to a few of them and say that, look, I like the papers or the thought processes that these guys are putting out,
Yeah.
and hence we could do this out of India as well.
Yeah.
Do you have those things, right?
I mean, to be very honest, when we started,
I raised this point with you, right? India
Yeah.
needs somebody from the science side to hit it big.
No, massively, right? And I think IIT Madras ecosystem has done very well.
Absolutely.
And now IIT Delhi, Kanpur, BITS, Pilani, all of these ecosystems are coming up.
Yeah.
I think we'll see way more deep tech entrepreneurs, science entrepreneurs coming up.
Not just from these places, but from the general
Yes.
university culture. as
Yes,
such,
I think these are starting to become the first hubs,
Yes.
like the torch bearers.
Yes.
And then of course
It'll
others.
trickle down.
Yes, it will trickle down, or the people from across India will come
They'll
to these
collaborate.
hubs. They'll
Yeah,
collaborate.
that's a better way of saying. Yeah.
Yeah, so this is going to happen. I think it's inevitable. There is some amount of risk funding available. Of course, one has to prove through a small POC and then a prototype and then functioning customer testing and beyond, because the risk appetite is still low. It's not like in US you get 10 million upfront. Let's be honest. So there is a way, but I think that way works. And then you can accelerate from there on.
No, I mean, I wish Planet Electric all the best. I wish you all the best, Gagan, and
Thank
you
you
and
so
your team.
much.
Thank you so much.
Thank you so much for having me.